Hello there! In this tutorial, you will learn about the tiled level editor. We are going to create a bunch of different levels in different styles. We will use terrains to create levels more efficiently. And at the end, we will cover how to import the level data into Pygame. And all of that should be fairly straightforward. However, before we get into all of this, let's talk about what tiled is and what problem it solves. Tiled is a level editor that allows you to import graphics and then place them in such a way that you end up with a level of a game. For example, we could load this graphic of a tile set into tiled, and then inside of tiled, we can pick specific parts of it and place it to build a level. And I guess to visualize this a bit more, here we are in tiled already. And in the middle, you can see my level that I'm building right now. And on the right, we have some graphics that I can pick from. And basically all I'm doing is pick different graphics and use them like a brush to create my level. That is the main idea of tiled. And since tiled supports a bunch of different export options, it is basically supported by any major game engine or framework. I will cover how to do it for Pygame, but if you look around, you find the way to do it for basically any other game engine as well. And tiled has actually been used for commercial games. Shovel Knight, Axiom Verge, and Carrion are probably the biggest ones, but there are quite a few more as well. It is a very powerful piece of software. To use tiled, we have to install it. And this you do from the website, which is looking like this. And in here, all you have to do is click on download, and then click on download again. And in here, you could pay any amount of money you want. And I would recommend you to pay at least a bit because a lot of work went into it. But if you don't want to, you don't have to. You can just click on no thanks, just take me to downloads. And then you can download whatever version applies to you. In my case, I am using the installer for Windows 64-bit. And chances are that you have the same version. So if I click on download, we get to a new website and we are downloading the program. In my case, I have already done this, so I'm going to delete it. But, well, in your case, you want to finish the download and then install it. And once you finish installing, you can open the program like any other program. And once you open it, you can see something like this. And in your version, you probably see the same thing, just a little bit brighter. The reason why mine looks different is because I, well, made it darker. And to make it look like mine, all you have to do is go to Edit, Preferences, and in here there's Theme, and we want to change the base color. And in here you have a brightness slider on the right side. And in my case, I put it down to something a little bit darker. And I think this is looking significantly nicer. But alright, now, what can we do in here? And right now we can see a bunch of options in the top left. And to understand what they do, we have to cover some basic functionality of tiled. And the best way I think to think about it is in terms of painting. Because essentially what we are doing is painting a level. And there are three elements that you want to be aware of. The first one is the canvas, so the element we are painting on. In tiled, that is the map. And this is what we can actually create here already. We are going to create this one in just a second actually. But then for painting, you need two more elements. You need colors and you need brushes. And the colors in tiled are essentially the tile sets. This is where we are going to take elements from and place them on the map, which is our canvas. And then the brushes are the selection tools in tiled that we can use to select different tile sets. But basically, all we want to do for now is to create, let me show my mouse. I want to create a new map. So I click on it, and now we get a few more options. At the top, we are getting map orientation, tile layer format, and tile render order. And most of the time, you only really want to care about the orientation. Because if you open this one, you get 4 different options. We have orthogonal, isometric, isometric staggered, and hexagonal. And these options are to create different styles for our game. Orthogonal is essentially the default, where you have square tiles where you can place different elements. So games like Mario or Zelda use this kind of style. Isometric is this 45-degree top-down look. Games like SimCity when it was 2D had that style, or Final Fantasy Tactics had the same style. And the third style is hexagonal, and if you think of Civilization, that's a hexagonal style. It's fairly rare, but, well, you can create it in tiled. Now in our case, I want to stick with orthogonal, although later on we are also creating an isometric tile set. Those two are the really common ones. And for tile layer format, we have different versions, and for tile render order, we also have a few more options, but none of those really matter. You just want to leave them as they are. But then when we look below, we have a few more options. We have map size on the left, and we have tile size on the right. And basically what that means is when we are creating our map, we are creating a map that consists of tiles. So the map is the larger canvas, and inside of this canvas, we have individual elements that look something like this. Let me draw a couple more. We are basically covering the entire map with tiles. And right now, our map is 35 tiles wide and 32 tiles high. That is the information you get here. And then each individual tile is 110 pixels wide and 64 pixels high. And these numbers mean that each tile inside of the map is 110 pixels wide and 64 pixels high. And for those numbers, you do want to be really careful, especially the tile size, because when we're importing a tile set, we have to work with a specific size. And if you mess up the sizes, you can get into a lot of problems. Actually, let's have a look at this in Photoshop right now. And all right. Here we are in Photoshop, and this is the graphic we are going to use in just a second. Now, for this graphic, let me zoom in a tiny bit. And basically how it works is that all of this is composed out of different tiles. And each tile would be something like here we have one tile, here we have another tile, and here we have a third tile. And this we are going to continue for the entire tile set. That's why it's called a tile set. It's a set of different tiles. It's amazing how that works. And the size of these tiles in the graphic has to be the same size as the tiles in our map. If they don't line up, you end up with a lot of problems. And in our case, each tile is 128 by 128 pixels. So that is the size we want to have for the tile size in our map. And when you open any kind of tile set, the first thing you do want to check is the size of each tile. It's usually 16 by 16, 32 by 32, 64 by 64, or 128 by 128. Although basically any size could be viable here. You really have to check. But all right, back to tiled. And what I want to do in here is create tile size with 128 and 128. And you can actually tell, now that we've changed the tile size, we get a new number down here. And that's the size of the entire map. And this number we are literally just getting by multiplying the width of the map with the width of each tile size. I guess we can make this really clear by changing each of those to 1 and 1 tile, and we get 128 by 120. But let me undo all of this. That is looking good. All right, finally, I can click on OK. And here you can see the actual menu of tiled. Now, before we actually implement anything, let me go through the different panels you can see right now. The most important element, the one in the middle, this one here, is called the map. And this is essentially our canvas if I stay in the drawing analogy. This is where we are going to create our level. The next really important thing is on the right. Here we have layers and we have tile sets. Tile sets is going to be the colors we are going to use later on. And we can create a new tile set here. We are going to do that in just a bit. Layers are basically different layers you can draw on. So if you want to put one element on top of another element, that's what you would use layers for. The next important element are these elements here all the way at the top. specifically this row here. These are essentially our brushes. The one we have selected right now, this one here, is called a stamp brush. That's like the default brush. But we also have a fill brush, this one here, and we have an eraser, and well, that one erases stuff. And those you would use to place tiles on the map, like you would use a brush to paint colors on a canvas. And then next up, on the left side, you have one panel with information. Right now it's for the map, but it could also apply to tiles. It really doesn't matter all that much, but well, if you really want to look up some information about the tile, here is where you would find it. And one more really important thing. We can see right now we have untitled TMX all the way in the top, and this is one tab. And every single map and every tile set you open is going to be another tab. That should be making sense in just a bit when I actually use it. But what I want to do for now is to save this file. And this you can do either under File and Save or with Ctrl S. And if I click on that, I get to my folder setup. And in here, I have 3 folders. I have Code, Data, and Graphics. And I want to go to Data, and in here I have TMX. And I want to give it a name. Let's call it Basic. And if I save it now, the name has changed to basic.tmx. Let's actually create a tile set so we can draw on this entire thing. And for that, I have to click on New Tile Set, the element here all the way on the right. And if I click on it, I am getting another dialog. And at the top, we have a name and a type. And for the type, we can select based on a tile set image and based on a collection of images. Right now, I want to stick with tile set image. And if you have this one selected, you have another dialog below. And in here, we have to browse for an image, which I do want to click on. And in here, I want to select my tiles. And click on Open. And now I have the path towards it. Before I can click on Save As, there are a few more options I do want to consider. The more important ones here are tile width and tile height. And those refer to the size of each tile inside of this tile set. This is basically what we looked at in Photoshop just a few minutes ago. And this number, you really want to be equal to this number here. That way our graphics and the tiles in our map have the same size. If they don't match up, you are very likely to end up with problems. Although sometimes you do want it to be the case, I will cover that later. Especially for isometric tiles, this is becoming important. But right now, we just want them to be equal, so we don't have to worry about it. Besides that, we have margin and spacing. And these are options you would be using if there are gaps in your tile set, which is a fairly common thing, but in my case, they don't exist. So I can leave those at 0 and 0. And with all of that covered, I want to click on Save As, and now I have to save a new file. And right now I'm in the TMX folder. I want to go up one folder and to my TSX folder. And then here, I want to save my tiles. And once I do that, I get a new tab. And this one you can see all the way up here, tiles.tsx. And if you want to return to the tile map, you have to go to the initial tab. And now in here, you can see all of the tiles of the graphic. And if you want to move around here, you have a couple of different options. Let me show the mouse again. So if you want to navigate this, you could either use these scroll bars, but that's kind of inefficient. Usually what you do is hold the middle mouse button and then pan around. That's much easier. And if you wanted to zoom in and out, you can use Control and the mouse wheel. That's basically what you want to use most of the time. And then besides that, you can click on every single tile and, well, select individual elements. Although you cannot use them in this menu. Instead, what we have to do is to return to basic.tmx. And in here, now, all the way on the right, you can see in the tile sets, we have our graphic. And inside of this, you can use the same navigation options. So if I hold Control and scroll out, I am making all of this smaller, so it's a bit easier to see. And now in here, you can see all of the tiles. You can also hold the middle mouse button and pan around in here. And now, basically, what you are going to do, you are selecting the stamp brush, the one I have already selected, or you could press B for the same result. And then you select one tile that you want to draw. Let's say this grass tile. And now on the map, I can just draw all of this wherever I want. Obviously, this one is looking terrible, so let me undo all of this. And instead, I want to place just a couple of grass tiles and then select other tiles to create a proper outline. Something like this. Right now, this is a very slow process, but we will learn about more efficient tools later on. But this allows us to basically place elements wherever we want on our map. And what you can also do is select multiple elements inside of the tile set. For example, if I wanted to place all of these parts here, I can select all of them. If I now go into my map, I can place all of them wherever I want. I can also drag them like any other brush, although that admittedly looks horrible. Let me undo it actually. Let me keep those. And by the way, in this map, you also have the same navigation options. So if I hold the middle mouse button, I can pan around. If I hold Control and use the mouse wheel, I can zoom in and zoom out. And now the other brushes you have. The next really important one is the bucket fill tool. And this one, well, it fills the entire surface. So let me select one of the dirt tiles, this one here. And then if I select anything on the map and click, we are filling the entire area with dirt. And this you could do with literally any other tile. And this one is context aware. So it checks for similar tiles. That's something you do want to be aware of. For example, if I zoom into the grass tile here, the fill tool only fills identical tiles. If we have a different tile, they would not be filled. And then the next important brush or well tool is the eraser. And this one you can use to erase things. Fairly obvious, I suppose. And I would really recommend you to practice all of this. I guess a good idea would be to create your own map from just using all of these tiles. So pick a couple of random ones and then try to draw an actual usable map and see how far you get. All right, let me get rid of all of this and let me show my mouse actually. I think that's going to be better. I first of all want to use the bucket fill tool and fill the entire area with dirt. Then I am going to zoom in, select the stamp brush, and now I have an outline, and this I can fill as well. Oh yeah, I didn't mention, the fill tool selects identical tiles if they are in an enclosed space. And now I have my grass area, and now we come to the slightly more boring bit. I have to create all of the outlines. That would look something like this. I am probably going to speed this part up because it is fairly monotonous. All right, and there we go. We have, well, something very basic, but this could be something you actually see in a game. And you might have noticed this is a really slow and annoying process. And later on, we are going to learn a better way of doing this. That is what terrain sets are for. But for now, this is the basic what you are going to need. Although now, imagine you want to place something on the right here, like this plant. If I place this plant somewhere on the level, let's say here, we have a problem that you can see the background. Let me zoom in a bit more. Here you can see the background, and this looks, well, kind of ugly. So what I want is to place this plant on top of the grass. Let me undo it. And to place something on top of each other, we need layers. And right now we only have one layer. And if I double click on it, we can rename it. Let's call this one the ground. And to create a new layer, I have to click on this symbol here. And here we have a couple of options. Tile layer and object layer are the most common ones. And I want to create a new tile layer. And this one also needs a name. Let's call it plants and rocks. And let me spell it properly. And now I can select the plant again. If I plant it, it's on top of the ground. And if I hide this layer, it disappears. I can do the same thing for the ground with the obvious result. And this way, I can place elements around wherever I want. And these layers here are really important to create more complex levels. For the bigger projects I made and tiled, I usually have something like 7 or 8 different layers. And in here, you do have to be really careful which layer you are drawing on. It happened to me really often that I think I'm on one layer and then I end up drawing on another layer. So for example, if I have ground selected and I draw something, I would end up with something really horrible, which I didn't want. And all I really want to say is be careful what layer you are on. It's very, very easy to forget what layer you are working on. Just keep it in mind. But all right, now, when I am placing, let's use something more recognizable, like this rock. I do have a couple more options. Let me zoom in a bit more to see it better. There we go. Now, right now, when I'm placing this rock, we always have the same rock. Although, if you look at the top at these 4 elements here, you can either flip the rock with these 2, or you can rotate the rock with these 2. And if I click on this one here, I have a rotated rock. If I click on the other, I have rotated the rock in the other dimension vertically. And this I can also do for the other side as well. And if you just use those 2 buttons, you already get very different looks, which can be a nice way to make your game look a bit more varied. And then besides that, you can also rotate the entire thing by 90 degrees. In this case, I guess same result, but you get the idea. And there's one more really useful button, and that's this random mode here, the little symbol of the dice. If I click this, nothing seems to change. Because for this one to work, I have to select multiple elements. So let me select all of these bits here, all the plants and rocks. And now, if I return to my map, you can already see the result. Let me zoom out a bit. Every time I go to a new tile, we get a different element. That is a random selection of these selected items here. And those I can just now draw on the map, and we get something completely randomized. And if you don't like one specific randomized item, you can just click again and you get something else. It's super useful. And what you can also do if you want to have some elements being more common. Let's say in my case, I want the plants to be really common and just once in a while have a rock. This you can also do, but we do have to return to the tile set. So in the tab, I want to click on tiles.tsx and move to these elements. And if I select any of them, on the right side now, we have the properties panel and we have a couple of options. We have ID, that's the number of the tile set. That's not really important. We can set a type ourselves, also not something we care about. We have width and height, also something we don't really want to care about. And then we have probability, and right now it's 1. And that is the one we are going to care about. Because what we can do in here is set this to a different number. Let's say in this case, I want to set this to 0.1. And if I click on the next element now, this bush here, this one still has the 1. So if I only selected those two elements in random mode, this small bush is 10 times more likely to spawn than this larger bush or tree or whatever it is. Let me save it and return to the tile set. And if I now select only those two tiles here, and random mode is still activated, I get lots of smaller bushes and only very rarely a larger one. And that is the idea behind this probability. And you can also select multiple elements and give them one probability. So I want to give all of them a probability of 1, and all the rocks get a probability of 0.25, let's say. And now, if I return to this tile set, select all of these elements again. If I now draw them, okay, that's a bit hard to see. Let me go to another area. If I now draw them, we get a lot of plants and very, very occasionally a rock, but it is fairly rare. There we get a few more. All right, this seems to be working just fine. And with that, we covered all the basic parts of a tile set. If you just want to create some basic things, this is all you are ever going to need. It really isn't that hard. Although there are a few more elements in tile that I do want to cover. The next one is objects. And there's actually a whole tab next to layers, objects, and right now we don't have any objects. And basically what objects do, there are just other graphics that you can place on the map, except that objects can have any size and you can place them wherever you want. Meaning they are not bound by this tile set, you can just place them wherever you feel like they should be. And especially if you have some more recognizable elements like a castle or a tree, you do want to use objects. And well, to create them, we first have to import them. And this happens again by clicking on this new tile set here. And this time, we don't want a tile set image, we want a collection of images. And those need a custom name. Let's say in my case, I want, let's call it objects. Now I click on Save As. Now I'm back in my TMX folder and I want to go one folder up, go to TSX, and then here I want to save them with the tiles. And I click on Save, and now I have a whole new window. And this one looks very similar compared to the tiles, except it's empty. And the first thing that we have to do is to import some graphics into it. And for that, I need my folder, this one here. And if I go to graphics, besides tile sets, we also have objects. And then here, I just have a couple of random images. And those I want to drag into tiled. If I do that, I can see my castle. And if I zoom out, I can see all of the elements. And right now, they all look like they have the same size. But if I click on the castle, for example, you can see it's quite a large image. And if I click on the mushroom, it's much, much smaller. So all of these images have very, very different sizes, which is completely different compared to these ones here. They are all identical in terms of size. And you could also set the probability. This one works in the same way, but besides that, there isn't really that much of a difference. But now, if I return to my tile map, I get under tile sets another tab. And this one is objects. And let me zoom out again. In here, I could select this castle, for example, and place it. Although if I am trying to do it, you get something weird that the tile I have selected and where I place the castle have no relation to each other, which is kind of annoying. And the reason here is that the castle is just way too big for the tile, so tile doesn't really know what to do with it. Oh, that was one too much. There we go. Now, to account for that, we have to create a new layer, which we do here. And now we don't want a tile layer, we want an object layer. And now we have to rename this new layer. And let me call it objects. And now we have a new layer. But more importantly, if you look all the way at the top, the icons we used before like the stamp brush or fill, have all been grayed out, meaning we cannot use any of these here. And instead, we have gotten a whole new set of tools, all of these here. And the one you are going to use the most is this one here. This is basically the stamp brush for objects. And this one is called Insert Tile. Now, if I select this one and now go back to my tile set, now I can place the castle wherever I want. It's in the center of my mouse, and it is not constrained by the tile set. I can move it around wherever I want. And this applies to all of them. So I can place some mushrooms, some trees, power, doesn't really matter. And all of this is done with this brush here, or this tool, whatever you want to call it. Besides that, the other really important one is select object, and this one, well, it selects objects. So I can select this one, this one, this one, and so on. And also, if you click on it twice, you get different options. The first one, the one with the arrows, allows you to scale the object you have. If you click on it again, now you can rotate the entire thing. And more importantly, if you look at the layers, there we have objects as well. And in here, you can select all of the objects that we have created earlier. And for each object, we can set a name and a type. Those you can see here on the left side. And let's say what I want to do. I want to select all of my castles. So I hold Shift and click on all of them. And I want to give each of them the name castle, and type is going to be building. And if you now look on the right side, we have now the name and the type for each castle. We can do the same for the towers as well. Those ones are going to be name tower, and type is also going to be a building. And besides that, we have some trees. And let's call them trees, or just tree. And type, let's call it vegetation. And then we have a ton of different mushrooms. And let's call those mushroom and type vegetation. And what you may be seeing, that after you have given them a name, you can always see the name on top. Whereas in my case, they only show up when I select them. This you get under View and Show Object Names. For you, I think it may be for all objects. In my case, it's only for selected objects. Generally, views is really, really useful. And, well, this is basically the start of what you would need to use objects and tiles together. I did forget 2 trees. Let me call them tree and vegetation. There we go. Now we have all of the objects. Now, there are a couple more, these 4 here. We have insert rectangle, insert point, insert ellipse, and insert polygon. And those, well, they do what the name implies. If I select the shape one and draw now, we are getting a rectangle. If I select one of the points, I can place some points. If I select an ellipse, I can place an ellipse. And the polygon allows me to draw a polygon like this. And then you could use edit polygons to manipulate each of these polygons if you really wanted to. And you do want to give all of them a name as well. So let me select all of the markers and let's call them name marker and type, let's call it a shape. Then we have the rectangle, and this one is also going to be a shape. And we have the ellipse and the polygon. Those are both going to be type shape, except for the ellipse. It's going to be an ellipse, and for the polygon, I want to have a polygon. There we go. Now, these elements you can import into any kind of game engine, but obviously right now they don't have any kind of graphic associated with them. What you would rather do is import the geometry, so you can get all of these points here. Let me draw, actually, that should be better. So what you would import later on is the geometry, like these 4 points for the rectangle. And those you can then use to draw whatever you want inside of it. So if you want to check if the player enters a certain area, this kind of shape is really useful. Same for the markers, like one of those. You can use them to place certain elements, like the main player, if you want them in a certain spot, like a starting position, for example. Now, one more thing that you could be doing is to insert text. And we return the mouse. This is this button up here. And if I click on it, we can place some text. Let's place it, I don't know, here. And right now, this is a very small text box. So what I want to do is to increase the width and the height of it. Let's say something like 400 by 400. The problem is the text is just generally very small. And I guess another thing I can do is change the text in there. Let's call it my awesome level map. And if you want to change the font size, you would go to font and also expand it. And in here, we can increase the font size quite nicely. So it actually shows up on the whole level. Yeah, I guess that works. And then you can also move this text around like any other element. Now, the only limitation with text is that importing it into Pygame seemed to be kind of impossible, or at least I didn't find a good way of doing it. Meaning that this would mostly be something used to annotate ideas in your level. But maybe you find a way of doing it. But with that, we have covered all the fundamentals of tile. Now, there's one more thing I do want to cover that is kind of important, and that is, let's say I take this castle and this tower here. And I move the tower in front of the castle. Now you can see, let me zoom in a bit, the tower is in front of the castle. But if I move the tower a bit further up, the tower is now behind the castle. So they are drawn intelligently to figure out which element is on top of which other element. That was a really weird sentence. You get the idea, that we get some kind of fake 3D that is really useful. And how we are getting this is when you create a new map. Let me create a new one, so new and map. This is the tile render order, this one right down here. And in our case, we are drawing elements right and down, meaning the further down an element is, the higher it is drawn in terms of, well, drawing. You could change it, but there's very little reason to do so. But all right, with that covered, we are basically done. If you just want to create a basic map, this is all you are ever going to need. And the games I've made so far, like Zelda and Super Mario, were made in just this style. That's basically all I did. Although there's one really useful tool in Tiled that you do want to use as well to work more efficiently, and that is terrains. Now, how terrains work is getting a bit more complex. So let's explain what they are and what they do. So let's talk about terrains. And basically, terrains are special tiles that react to their surroundings. And what does that actually mean? Let's do an example. Say you have this kind of case here, where you want to figure out what this tile is going to be. And this one should be fairly obvious. You want to draw the tile that connects these two like this, with everything else being just dirt. And this means if you know this tile here, and I guess you know that this tile and this tile are empty, you already know what tile needs to be in here. You want to have the corner tile set. And this is something we have done manually so far, but tiled can also do it because it's a fairly easy process. And this is what we are going to create. However, to create a terrain, we have to talk about something else because there are different ways to create one. Let's go through them actually. Overall, there are 3 different ways to create terrain tiles. The first one is you look at the corners. And this white rectangle right now is 1 tile. And on this tile, we want to check all of the corners, these 4 here. And if this tile borders on another tile, so let's say we have another tile here, all the way to the right, and then for these tiles we know that this top one here is grass, and the bottom one is dirt. And if we have then connecting corners on the other tile, so we know that on this right tile set, we also have grass in the top left, and we have dirt in the bottom left. If that is the case, we know we want to connect these 2 tiles here. And that's the first case. The second one is we are looking at the edges. So instead of looking at the corners, we now look at each of these connecting points. Meaning if we have a tile to the right again, like so, we only look at if this tile here and this tile here are identical. Say if both of those are grass tiles, then we want to connect them. And we don't really care what happens around the edges. And finally, we have corners and edges. And this is a terrain set that does get really complicated because we are checking all of the corners, these 4 here, like we have done in the corner set, and we are also checking all of the edges, like so. Which means if this tile set has a tile to the right, we have to check 3 different points. For example, if the bottom right of our tile is grass, the middle one is dirt, and the top one is water. We are only going to connect the tile to the right if this also has water on the top left, dirt in the middle on the right, and then grass in the bottom left. Meaning for this kind of tile set, we have to have a pretty complex setup. And for this video, I am only going to cover corners and edges, for the simple reason that creating a corner and tile set takes forever. You're going to see very fast that creating tile sets can be a really, really long process. But let's actually have a look at this in practice. All right, here we are back in tiled, and I have 2 tile sets that are simplified that I want to use, meaning I want to create a new tile set. So I click on new tile set, on browse, and then here I have terrain corner and terrain edges. And let's start with edges, that's the easier one. And all of these other attributes can stay the same. So save as, and I want to save all of this in another TSX file. And let's leave terrain edges, that one seems totally fine. And now we have a new tile set. And then here, again, we could just select individual images. It's the same format we have seen here, where we have just a couple of tiles. So if you want to go to the level, you could pick the terrain edges and just start drawing on it. Not on the objects layer, but on this one. So you could just create tiles here. This one is just the same. But I want this to be automatic. And for that, in the terrain edges, I want to select this terrain set symbol here. If I click on it, we get a new panel on the right. And in here, we have to click on the plus at the bottom. And now we can see what I just talked about. We have a new corner set, a new edge set, and a new mix set, which combines the corner and the edges. And now to see if you paid attention. Is the tile set we need a corner set or an edge set? Try to think about it for a second. The tile set we are going to need is an edge set. So let me click on that. Let me zoom in a tiny bit on this tile set here, for example. If we look at this tile here, the outline would look something like this. And what we are looking for is if there's a connection here, 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 or here. Or I guess in this case, we want to make sure that there's no connection on this tile here. But you can already tell we don't check the edges, like so. And this is why we need the edge set. If we were to use these tiles here, for this one, we do check the corners. There, it would be different. But this is not what we're worried about right now. We want to create an edge set. And first of all, we have to rename things. So the terrain set, I want to call, I guess these are pipes. I can't really tell what they are, could also be a path, doesn't really matter. And then inside of the terrain set, we have to give this red thing a name as well. And I want to call it yellow. And we could create more than one in here. We are actually going to do that in just a bit. But for now, we just keep it at one. And now, if you hover over the tiles, you can see a red thingy. And what we have to do is tell tiled where we want these elements to be. And you can already tell how this is working. So I know for this tile, it connects on the left and at the bottom. This is where I'm placing the dot thingies. And this I have to do now for every single one of these tiles. Although this one, leave out for now. You're going to notice in a second why. But all the other elements, I just want to keep on drawing different points. And there I just made a mistake. I'm going to fix that in a second. And for those individual tiles here, they only connect in one way, this one here. And now I have to fix one error, and that's this part here. And for that, I click on Erase Terrain and click on the point I want to erase. And now we have all of the corners. The green stuff here, you can just ignore. And this part we are going to add in just a bit. But now I want to save this terrain set and go back to my basic tile. And now nothing has changed. But if I click on terrain set, now we have pipes, and there I can select yellow. And let's put all of this on a new tile layer, and let's call this one pipes. Oh, and now also importantly, in the top left, we have the terrain brush selected. And what I can do now is just draw a pipe wherever I want, and it always connects just fine. And this is working really well. So this is obviously looking horrible, but it does work really well. Although, let me undo all of it. It does look pretty bad. I just want to have a more simple one. And let's just draw it like a simple circle. Now, what you want to be aware of. If I return to the tile set, right now we didn't use this tile set at all. But if I add it as well, just the corner, and now return, and draw another circle. It works the same, but now we get a sharp edge. And there we get a sharp edge as well. And what basically happens here, let me return and start some drawing. Let's say we're looking at this tile here and this tile here. And if you look at those two in isolation, you can tell that from tiles perspective, those are identical. They both connect on the right and at the top. Meaning for tiled, it doesn't really know when to place which of these. Meaning tiled is going to randomly select one of them. And that is what we have seen in here. Where sometimes we are placing a round corner like here and here. And sometimes we're placing a sharp corner like here and here. And those are being selected randomly. And this right now is fine if this is what you are looking for. But this sometimes can cause a lot of problems. We are going to see a case like that very soon actually. But this is the basic idea of a terrain tile set. And this one is generally super useful. So I guess let's continue to the other kind of tile set. This one is even more useful. And that is going to be a corner set. And for that, we actually have to import another tile set. And that tile set is basically this tile set here, except in simplified. So let me reveal the mouse. I want to create a new tile set, and this has to be a tile set image. And from here, I want to browse and create a terrain corner. And this I want to open, and everything else can stay the same. And this I want to save as in my data as tsx terrain corner. This one is just fine. And now in here, I've added some text to illustrate what we are going to work on. And for now, we are just going to focus on this part up here. The problem bit you can ignore for now. I'll get to that one in just a second. But really, all I want to do in here is create another terrain tile set. Let me show my mouse again. And for that, I have to click on the plus. And in there, I want to create a new corner set. And this one, let's call it ground. That is not proper spelling, ground. There we go. And in here, if you look at this tile set and compare this one to the edges. For the edges, we only had a single kind of tile. It was always this yellow pipe thingy. But for this one, we have two different kinds of tiles. We have dirt and we have grass. So inside of this terrain set, we need two terrains. We need, first of all, some dirt. And then I want to click on this plus down here. And this allows me to add a second terrain. And that is going to be the grass. And well, once we have that, we can follow the same process. Except now we are filling in the corners. So for example, let's do this tile here together. I know that this corner, and this corner are all supposed to be for dirt. And then this grass corner here is going to be this corner for grass. And now this we have to do for all of the other tiles as well. And I think this could be a really good challenge for you. Try to add all of the terrains for this tile set here and ignore the problem bit and see how far you get. All right, let's do it together. And let me start with the grass, but it doesn't really matter in which order you start. And all of these grass tiles, I have to go through those, and those. And that should cover all of them. Now with the dirt selected, I can select all of the dirt tiles. These corners here, all of those, this, and this. And in here, we have the same issue again, where we have two tiles, if I select all the corners here, where these two rectangles here, two tiled, are identical, meaning it's going to pick one of them randomly, which in our case is perfectly fine because they are, well, essentially identical. So if you pick one of them randomly, we don't really have to worry about it too much. Although, what we can actually do, if I go back to the selection box here and select this tile, the probability is still going to work. So if I set this to 0.2 and return to my terrain, then this tile here is going to be placed much less often. So that is really, really nice. But all right, with that, we have our terrain set. So I want to save it and return to my basic tile set. And now in here, I want to create a new tile layer so we have some empty space to work on. And let's call it floor. And this I want to be below the pipes. And I guess for now, let me just hide everything else. And now we have some space to work. And I want to look at my terrain set. And now besides the pipes, I have ground. And inside of ground, we have dirt and grass. And now if I try to draw with my dirt, nothing happens. And if I draw with my grass, nothing happens either. So what is the problem here? Although the pipes, if I draw those, they still work just fine. So what's the issue here? And well, if I go back to the terrain corners, what you have to understand here is that all of these tiles work in relation either to grass or to dirt. So tile basically needs some kind of starting position, which we don't have right now. And all that really means in practice, if I go back to my basic set, I want to look at my tile sets and my terrain corner. And we basically have to fill the entire map with one of these tiles here. In my case, I want to pick the basic dirt tile. And do make sure here you actually pick from this terrain set. You could also, by mistake, use any of these, and that wouldn't work. Because to tiled, this dirt set here, zoom in, this dirt set here, and this dirt set here to us look identical. To terrain, they are completely different things. They just happen to have the same information. But tiled needs some kind of starting point. So we have to pick one of these tiles here. Doesn't really matter which. But once you have done that, you can go to a terrain set, pick grass, and now we can draw on here, and we are getting proper shapes. This is looking quite nice. And of course, we can also use dirt and draw over all of this, add some insets, and create islands, or really whatever you want. And well, with that, we have our basic set. That's kind of it, to be honest, in terms of simplicity. So let me create some basic tile sets here that look a bit more like an actual game. I guess let me add here one as well, just so you can see what's going on. So with that, we have some basic terrain sets. That really wasn't all that difficult. Now, the problem is that this is still a very simple tile set, and there are quite a few things that could go wrong. And I guess let's have a look at this tile set here to see what could go wrong. And I think it's best to just add these tiles here. So I want to add some dirt tiles, all of these. And besides that, I want to place some grass in these tiles here. And with that, we do have a terrain set that looks good on the surface, but this terrain set is very broken. And if we use it, you can see that pretty fast. So now, if we want to add some more grass and place this here, we get something weird. Let me zoom in. And I guess we can draw on this as well. That should help a bit as well. Essentially, what we are seeing here is that tiled is not sure what to place when it's placing a tile like this, where we have grass on the bottom and dirt at the top. So sometimes we get a large tile like this, or we get a smaller tile like this one here. And the same issue happens on the other side as well. So sometimes we have this small green tile, other times we have this larger green tile. So what's the issue here? And to understand what's going on, we have to return back to our terrain corner set here. And what you probably want to look at is this tile here and this tile here. I think that illustrates the problem the best. If you just look at those tiles, I think you can understand the problem. To tiled, these two are identical. Both have grass on top and dirt at the bottom. Meaning tiled is just going to pick one of them randomly. And since those two tiles look very different, this is not going to work. And as a consequence, we are getting the problems we have encountered. And this is not an isolated problem. For example, this tile here is identical to this tile up here. And since those two are looking very different, this is just going to cause more problems. As a consequence, you do have to be very careful how you place tiles. And this sadly is just a thing you have to get used to. It does take a lot of practice to create good terrain sets. So let me get rid of all of this. And back in the terrain set, let me undo all of this. That's looking better. Cool. Now, one way you can approach this is if you look on the right, there we have patterns. And this is actually incredibly useful because in here you can tell what tiles have been covered. Essentially, what this thing tells you what tiles you need for proper working terrain. And right now we have all of these, so the terrain set is working. But if I erase, let's say, this tile here, then tile is going to tell me it still needs this one by highlighting it. And if I undo it, now it disappears. So this pattern here is really useful to see what terrain sets you are still going to need. What it doesn't tell you is if you have a certain terrain tile twice. For example, we have 2 red terrain sets, and this isn't reflected here at all. And the problem we had earlier down here is that we did have a duplicate, and one of the duplicates wasn't fitting in the terrain set. And that's just something you have to be really careful about. It's, well, one of the major problems with terrain sets. But this is essentially a simple terrain set for corners. Now, what you also want to be aware of is that this is still very simple. What you could do in this terrain set here, where I took the graphics from, we have quite a few elements. We have, let me actually create the terrain. So I want to create a new corner set, and let's call this one ground 2. And in here we have dirt, and we also have grass. And besides that, I guess this is sand, and this would be pavement. So I want to add sand, and I want to add pavement. Now, if you wanted to create a terrain set for these 4 options, you have to do a lot of work, because if I look at patterns, you have to cover all of these different options to have a working terrain set, which would be taking you a lot of work, and not all of these options are included in here. So you would also need some Photoshop to create new tiles. I guess the effort here would be justified if you're creating a really large game and you would reuse the tiles all the time. If you make a smaller game, this would be way too much work. So just keep that in mind. And on the topic of really complicated work, you could let me create another terrain set. And this time it's a mixed set. And let's call this one just test, doesn't really matter. And in here, I want to create another terrain. Let's call them test 1 and test 2. Doesn't really matter what they are. And now, if I look at patterns, it gets even worse. Because for these, we have 9 different edge tiles that we have to take care of. So if I were to draw them in terrains for test 1, in here, I would have to cover 9 different points for each tile, which would end up incredibly complicated. And this you would really only do if you're working on a very, very complicated tile set that you want to use for a fairly complex game. But in my case, this really isn't anything I would want to engage in. So let me ignore all of those. And well, if you have to work with them, just be prepared. You have to put a ton of work in there. Also, another thing you want to take care of is in this tile set, these dirt tiles here and these are different if you look at them in detail, because those have a texture, those don't. So this would make the entire thing even more complex. And I guess all I'm really trying to say is mostly stick to simple terrain sets. It gets really complicated really fast. All right, and now with that, let me make the other tiles visible again. And I guess now for the pipes, I want to get rid of those and create some tiles that work a bit better with the stuff we have. So let me select the pipes, and I want to create some yellow tiles that, let's say they start something like this. And we go down here and here and something like this. Okay, this does look horrible. I just want to cover the entire map with pipes, so things are looking halfway okay. And well, with that, we have corner and edge terrain sets. And if you really want to, you can also use ground and test, although you would have to put a lot of work into making these, well, work. But I hope you understand the principle. If you make something really complicated, this is incredibly useful. And with that, we have been making some pretty good progress. There are two more topics that we do have to cover. First of all, how to export something, and second of all, isometric tiles. I guess we could start by exporting something because we already have this tile and this is what I want to use in Pygame. And well, you have quite a few options, most of them either in export, export as, and export as image. Export as is usually the place where you want to start. So if I click on it, we are seeing an export as dialog, and here I am in my folder setup. And I want to create a new folder, let me call it export. And if I open this one, I have quite a few different options to export something. The one that is usually the default, I think, is tile map file. So we're just exporting a TMX file. But you can also use CSV, GameMaker, JSON, JavaScript, Lua, and GameMaker. And those are some really popular game engines. So if using one of those, you can totally export it in the file format that works for you. Although in my case, I am going to use TMX, so I can click on Save, and we have an exported file. And if I open the File Explorer, in here we have export, and we have basic.tmx. Now, this basic.tmx and this tmx here are essentially the same file. I think they are literally actually the same file. So exporting tmx and just saving it pretty much gives you the same result. Most of the time, if you use export as, you will probably use something like CSV or JSON. And let me demonstrate what CSV does. For this one, I can save again. And if I now open the folder, we can see 4 CSV files. And they all start with basic and an underscore and then the name of the layer. And let me click on basic floor. And now we can see a ton of numbers. Now, what does all of that actually mean? And let's do this by example. For now, keep in mind this 27 in the cell A1. And if I return to tiled, we only want to look at the floor layer. And in here, we have this terrain corner tile set. And the tile that we have in the top left right now is a simple dirt tile set, this one here. And if I click on this, in the top left, you can see ID 27. The same 27 that we have in the CSV export. And this is what we are actually exporting. And basically what is happening is that tiled assigns an ID to every single tile inside of this map. And the ID is coming from each individual tile set. Meaning if I opened terrain corner and select this third set here, we have ID 27. And this is what gets exported as CSV data. And this information is generated by tiled starting at top left and then giving an increasingly larger number to each tile. And you really want to be aware of here that we are literally only exporting a number. We are not exporting a position, we are not exporting an image, all we have is the ID number of each tile. And even worse, this ID tile is not unique, which means if I look at this ID tile, this corner here has the ID 8. And if I go to terrain edges, I can look around and I am probably going to find ID 8 again, meaning this ID here is not unique, which would be quite a big problem if you're trying to import it by just using the ID. So just keep that in mind. I guess you could find out the position though, and how that would work. Let me open the CSV data again. If you want to find out the position of any of these tiles, let's say the position of this top left tile here, you would essentially look at the row, so row 0 here or row 1, and then the column. And from that, you can figure out where this tile is supposed to be placed. And this works for any of these ID points. I have actually made an earlier tutorial on tiled, and in there I have used CSV data. If you want to check this one out, it goes over how you would do this in practice in Pygame, although it really isn't the most straightforward process. So not recommended by me. But right, this is basically how you would export things most of the time. Now, what you can also do is export as image. And if I click on that, we are just exporting what we are seeing right now as one image. And well, you can select a couple of extra things in here. I don't care about them. I just want to export. And if I now open the File Explorer again under Pytmx, I can find the basic export. And this is information you can also use in any kind of game. Most of the time when I use this option, I want to have a floor for the game that isn't really doing anything except move along with the player. So just having one floor for the entire game is usually quite a nice thing to start your game with. But you could also use TMX data here. This would work just fine. I'll show you in a second how that would work. And well, that is basically all you are going to need for exporting data in tiles. And well, next up, we can start working on isometric tiles. Let's have a look at that. All right, now, before we start coding, there's another kind of tile set I want to cover, and that is isometric tiles. And those are, like you see here, these 45-degree angled tiles that do work slightly differently, but we can create them quite easily in tile. So I suppose we can jump right in and let's have a look at this. Here I'm back in tiled, and I want to create a whole new map. For that, I go to File, New, and New Map. And in here, instead of orthogonal, we need isometric. And the map size is still perfectly fine. You can essentially choose whatever you want in here. However, for the tile size, we have to do something different. And let me open up the graphics for this part. They are going to look like this. We're going to import them in a tiny bit. And each of those graphics, they are all individual graphics, and they're all 111 by 128 pixels wide and high. And what we need in the tile map for the file size is something different than the size of each individual graphic. Now, the width can stay identical. So I want 111 in here. However, for the height, we want half the height of this tile height. The reason for that is that all of these have to overlay each other. So we want to cut some parts off. And depending on the graphic, you might need some different things. If you have your own isometric tile set, you definitely want to play around with this. But in my case, I want 128 divided by 2, which is 64. And now I can click on OK. And now we have an isometric tile set. And this I do want to save. And let's save it in the same folder, and let's call it ISO. And this now is going to be an isometric tile set. You can see it quite well. Although if I try to use any of the tile sets we have so far, it just looks very weird. So this is no good. We need another kind of tile set. Or well, we need different graphics that work with this kind of tile set map setup. And for that, we have to create a new tile set. And this one is a collection of images. And let me save this one as Isographics. That is not how you spell that. Graphics. There we go. And save as. I want to go to my TSX folder. And then here, Isographics. And now, again, I have an empty folder. However, if I open my graphics, I can just select all of them and drag and drop them in here. And now I have all of my graphics available in here. And they all have the same size. That is important. And just to be specific here, they all have a width of 111 and a height of 128. However, if I return to the ISO tile set, each of those tiles is going to be half as high as that. So now we have a difference between the size of each tile on this map and of the graphics. Now, in practice, this really isn't going to make that much of a difference. But if I now select the ISO graphics, those, you probably have a bit more space on your screen than I do. But here we have all of them. And now, basically, all you have to do is pick different tile sets and place them. This is going to work in just the same way. So I can just place all of these. Let me fill in the gap. This does actually also work with the fill tool. So I just pressed F to select it. There we go. And I guess let me get rid of this part here. Looks a bit silly. And what you have to understand about isometric tiles is height. So right now, this might be our lowest layer. Let's call this one the floor. And if I want to put anything on top of them, I would need another layer on top of that. Level 1. And in here, I think what I did earlier was pick a couple of brick tiles and just place them around like so. And that way you can make the outline of a house. I am really not good at placing these. It does take some effort. I think actually I used this tile at the beginning. This one is looking a little bit better. And with that, we have the first level. Now we need level 2, and we can do the same thing and just draw more things on top. It really isn't that much more complicated than that. And unfortunately, in tiled, we don't have auto tiling for isometric tiles, which does get a little bit annoying once in a while because this can be very labor intensive. But, well, definitely does work. And once you have this, it's, well, an isometric tile set. Let me not show the grid. And this is how it would look in the game, which I think is looking really, really good. And, well, with that, finally, we can actually start importing all of this into Pygame. Now, in my case, I am only going to import this tile set here. And let me make all of this visible. There we go. And I guess let me put the plants and rocks on top so they can be seen. This is what I am going to import into Pygame. Now, you could also import this one here, although the logic would be slightly more complex because you have to account for the isometric tiles. But I'm going to focus on just the most straightforward one. So let's talk about how to import tiled into Pygame. And fundamentally, there are two different ways. The first is the more manual way, where you are importing some CSV or JSON data, and this would only give you the ID of every individual tile. But from this ID, you could select specific images and then put all of this into Pygame. It is possible. I have actually done it myself in an earlier tutorial. You can check that one out if you want to understand the logic. Problem is, this is a really, really extensive process that takes forever, and there is an easier way. And the easier way is called Pytmx, which is a whole Python module that takes care of all of this for us, which is a much easier way of doing all of this, which is why I'm going to use it. Now, to use it, we have to install the Pytmx module. And to achieve that, we need either the PowerShell or the terminal, in my case the PowerShell, and type pip install pytmx. If you're on a Mac with a terminal, this is probably going to be pip install pytmx. But in my case, Windows pip install pytmx is fine, and I have it installed. It only takes a second. It's a really small module. And once we have that, we have all we need to start coding. So let's have a look at all of the code we have. All right, so here we are in just about the simplest code you can have for Pygame for a start. If I run the code, we get a plain black window that doesn't do anything, which is perfect for our purposes. And now, to get started with using Pytmx, we have to import the module. And here we only want one very specific part. And basically what we want is from pytmx.util_pygame import load _pygame. And Pytmx basically has a couple of different submodules for different gaming modules. And Pygame is one of them, and this is a really neat function that allows us to work very, very efficiently with Pygame and tiled. It's super useful. Although, if you don't use Pygame, there's also a more general one that you could use as well. It's really up to you. But in my case, I want to use load Pygame. And now, what we first of all have to do is to load our tmx file. And this I want to store in a variable that I call tmx data. And all I have to call is load Pygame. And then here, I need the name of the file, or well, the path to the file. And in my case, I want a string. I go up one folder, then I go into the data folder. In there we have tmx, and inside of the tmx folder we have basic.tmx. And if I run the code now, we, well, still can't see anything, but we don't get an error. So we know that this path here is working. As a matter of fact, what we can do is to print what we get. So tmx data, and we are getting a tile map object. Still not particularly helpful, but something more useful that we can do is put this in a dir method. And if I run this code now, we can see all of the properties and methods that we have available. And if you look at this list, you can already tell pretty well what is useful in here. We can, for example, get a layer by name. Or we can get all the visible layers. We can also get all of the objects, all of the layers, and quite a lot more. There's a ton of stuff you can work with in here. And even more, you could add a whole layer to the tmx file or a whole tile set. It's really up to you. There's a lot of stuff that you can do. So how can we make sense of all of this information? And I think the best way is to think of it like this. Right now, we have a map or a tmx data file. And this is going to be the broadest information or the general container for all the other elements. What we want from this most of the time is some kind of layer. We want, for example, one layer for the tiles, and we could also want a tile for the objects. So we have to figure out some ways to get the layers inside of tmx data. And for that, we have a ton of different ways. I guess the most obvious one is tmx data.layers. And let me print what we get. And I don't care about the window. If I run this, we get ground, floor, plants and rocks, pipes, and objects. And on top of that, we also get information what kind of layer we have. For example, ground is a tile layer, whereas objects is an object group. So you already can tell quite well what you are getting in here. And I guess let me add a comment here. Let's call it get layers. And this would be get all layers. Now, besides that, we can also get tmx data.visible layers. And if I print that one, now we're getting a generator object, but it basically contains the same information we have here. So what I can do, let me cut it out, and for layer in what we just got and print layer. If I print this now, we get basically the same information we had earlier. So we have ground, floor, plants and rocks, pipes and objects, the same thing we had in here. It's essentially the same information with one twist. If a layer is invisible in tiled, it's not going to show up in here. So let me return to tiled. And right now, all of the layers are visible, which you can see here with the eye symbol. And let's say I want to make ground invisible since we are not using it anyway. And now, really important, this little star in the top left has to disappear, meaning we have to save it. If we don't save this file, it's not going to show up when we import it into Pygame, which I think makes sense. And let me run the code again. and we still don't care about this. Now there's no ground in here anymore. We are only getting the visible layers. And let me add a comment here, get visible layers. Another thing you can get is tmx data dot layer names. And if I print that, we are only getting the layer names. Although this time we are getting a dictionary, but this one is fairly similar compared to all layers. There is quite a bit of redundancy in here. So I'm not going to cover it in too much detail. There's one more I do want to cover, and that is tmx.data.getLayer by name. And then here we need one argument, and that's the name of the layer. And one layer that we have is called floor, for example. And now if I put all of this into a print statement and run all of this again, we are just getting the tiled layer floor all the way at the end. So let me add comments. This is get one layer by name, and we want get all layer names as dictionary. Now, there's one more thing that I do want to cover. And that is that sometimes you do only want the object layers. And this you can get with tmx.data.objectGroups. And this is going to return an iterable. So we need a for loop. Let's say for obj in tmx.data.objectGroups. And then here I want to print my obj. And let me comment out all the earlier stuff so things are a bit easier to see. If I run this now and close this again, we have one layer that is an object group, and that is called objects, which is what we have in tiled as well. So let me add a comment here, and let's call this one get object layers. And those are essentially all the different ways you would be getting different layers. Either tile layers or object groups or object layers, it's the same thing. Meaning, if I return to my drawing, now we basically got the tiles and the object layers. So all of these are mostly tiled layers, and this one here is the object groups, which is bringing us one step closer to actual objects that we can work with. What we now have to figure out is inside of the tile and the object layer, we want to get individual tiles. That's the next major step. And for that, let me add another section. Let's call it get tiles and objects. Actually, let's just focus on tiles now, because tiles and objects do work slightly differently, not that much. And just to keep things simple, I want to get my floor tiles. Let me copy this one, and let's call it my layer. And this is going to be my floor layer. And besides that, I'm going to comment out everything else. Now, what happens if I print the layer? We are getting not something that is particularly useful, because what we want in here is dir, which is a surprisingly useful function. All right, now, what we get as the properties and methods for a layer. All of the stuff that we have in here is going to be useful to us. And tiles is pretty much the most important one that you are going to work with the most. Let's have a look what this one does. I want to print layer.tiles. And this is a method, so we need brackets. And let's see what we get. We get a generator. So let's loop over this one. I want for tile in layer.tiles and print the tile. If I now run this, what we get is an X and a Y position. Let me go all the way to the top. There are quite a few. We have a very large tile set. Basically, what we get, here you can see where it's starting. We first of all have an X position, and this is for the tile. Then we have a Y position, and then we have a surface. So we are getting 3 bits of information. That is actually all we need. And I am going to use all of this information in just a bit, but this is pretty much all you are ever going to need. Now, how you would actually use this in Pygame is not by looking at the entire tile. Instead, you would, for X, Y, and surface, in layer.tiles, and then you want to print X, you want to print Y, and you want to print this surface. If I run this now, we are getting the X position, the Y position, and the surface. Although, be aware here, X and Y position refers to the tile inside of the map, not an actual X and Y position. To get that, we would have to multiply it with the size of the tile set, which in this case is going to be 128. So this would give us the actual position on the map. And once you have that information, you can just use it. That's basically it. But let's have a look at some other things in here. Besides layer tiles, you can also call layer.data. And this is going to return CSV information. Let me print it, and I think this is going to return an iterable. Oh, it actually doesn't. Cool. So here you can see how the CSV data would look like. Not particularly useful in this case because tiles is much more useful, but you could be working with it. Although, let me comment this one out because it, well, is very space consuming. Now, besides that, you have layers.name, and this one should be fairly obvious. And this should just be layer.name. And we get floor, the name of the layer, and we can also get layer.id. And this is going to return us the ID of the layer. You don't really use ID very often, name as well, but I just wanted to mention it. But basically, this is all you are going to need to get different tiles. Most of the time, you are just going to use .tiles and you get all the information you could ever want. So this is get all the information. And well, with that, we have different tiles. Now, besides that, we also have to get objects. And for this one, let me comment out this one here. And I want to create a new variable. And let's call this one object layer. And for this one, I want to get my Pytmx data and again, get a layer by name. And this time, I think I called this layer objects. Let me print the object layer and see what we get. And we get a tiled object group, objects. So this is going to contain all of our objects. All right, now, when we print dir and the object layer, we are getting the window again. This is getting a bit annoying, but in here we have a ton of things that should look fairly familiar. We have, for example, the ID, and we have the name of the layer, and some things that I think are fairly obvious. For example, we could append something, we could clear the entire layer, we could also remove certain elements. It's quite obvious what happens with these. We can also check if it's visible or not. But the one thing that we don't have in here is some way to actually get all of the objects. So if you read through this, there's nothing that says get objects or something like this. The reason for it is that we don't need to, because this object layer can be iterated over. All I have to do is for obj in my object layer and then print obj. If I run this, we are getting all of the objects in the game. And there's actually another way to get this. So let me comment out all of this. And what I want to do is tmxdata.object. That's horrible spelling. Objects. There we go. And this is returning the same information as this bit here. Meaning we can run a for loop. So for obj in all of this, and print obj again, and we are getting exactly the same result. So 2 different ways of getting the same outcome. Now, I tend to prefer the first approach because this one is a bit more deliberate in terms of how it works. Especially if you have more than one object layer, this one tends to make a bit more sense. For obj, let me run the dir method. And now we're getting a ton of information. And this is all the stuff we need to access an object. And the really important attributes in here are x, y, and image. Image being the surface for this object. And once we have that, we basically have, well, all we need. Although there are a few more things that could also be useful to you. For example, we have rotation, we have width, we have height, we have ID. We could get the name, and there's also the type. And those also tend to be quite useful. But image, x, and y are the really important ones. Oh, also there's S points. When we are working with the shapes, this one is becoming really important. But essentially, all we are going to do is obj.x, then obj.y, and obj.image. If I run this, we are getting the x, the y position, and the image or the surface. Now, these at the bottom here don't have an image because they are the shapes. But if I scroll up, we are getting a bunch of surfaces. For example, the first one, that's the castle. It's an image that's 768 by 768 pixels. And this one is in the position of these 2 coordinates. And, well, with that, we have all we need. I guess there's one more thing that we do have to cover, and that is the S points. What I want to do is inside of this for loop, I only want to get my shapes. Let me return to tiled actually. And in here, you can see all of my objects. And what I want to do is only get the objects with the type shape. And this could be a good exercise for you. Try in the for loop to only get the objects that have the type shape. And I guess when you have that, print the objects. Doesn't really matter what you do. All right. Basically, all you have to do is if obj.type is equal to shape. And this has to have an uppercase S. And if that is the case, I want to print the object. So now if I run this, we are only getting the different objects that are going to be shapes. And in here, the marker is the easiest one. So let's work with this one first. I want to add another if statement, that if obj.name is equal to marker. And now if that is the case, I want to print obj. If I run this again, now we are only getting the markers. And for reference, here we are back in tiled. And if I scroll in a tiny bit, a marker is this tiny thing. It's basically just a point on the map that doesn't really do anything besides that. So all we would ever want from this is an x and a y position. And this we will get with obj.x and obj.y. Meaning if I run this, we're getting all of these points. And this could, for example, be the starting position for a player. Or really whatever you want in here, it's a fairly generic position. And that is all you would really want to do with the markers. They do have height and width and image in them, but all of them return none or 0, so it's not really useful. Now, the more interesting object is if obj.name is equal to the rectangle. And let me comment out the markers so things are a bit easier to read. And let me print the obj in here. And this rectangle does have x and it does have a y position. If I run this, we're getting this information here. If I go to tiled, we are looking at this rectangle here right now. And you can see we have the same position. And besides that, we could also get the width and the height. Let's actually do that one. So I want to copy this again. I want to get the width and I want to get the height. If I run it now, we are getting more information. And if you just want to draw a rectangle, this is basically what you would use. Although you could also object s_points and run this. And this one would return all of the corner points of this rectangle, which I guess could also be fairly useful, although using those 4 bits of information is probably more useful. Now, besides that, let me comment out this one here. We could look at if obj.name is equal to ellipse. And let's check if this is working. So get my object. And this should be a comparison operator. There we go. Now we have the ellipse. And this one is going to return the same information we have seen earlier. Now, unfortunately, there's no radius in here. So if you wanted something round, you would have to use the height and the width and then use that to create something round yourself. Sadly, there's no easy way to create a rectangle here. I guess you could use, if it's a perfect circle, either the width or the height as the radius. But, well, that is all that is to that one. And finally, we have if obj.name is equal to polygon. And in here, we can print the object again, although that isn't going to do too much. We're getting the same information again. The one important thing here is as points. And if you run this now, we are getting the points. And here it is very important that those are the bounding box of the rectangle. They are not the actual polygons. For that, let me duplicate this line. You would just need points. So if I run this now, these points here are the actual points of the polygon. These points here are the bounding rectangle. And let me visualize this in tiled. We are looking at this object right now. And as points returns this bounding box here. Whereas if you just use points, you're getting these 5 points here. Very different information. But with that, we have covered all of the different shapes that you could ever possibly work with. As a matter of fact, we have covered everything that you would need for the basics to use Pytmx and Pygame. That's kind of all you need. So I guess with that in mind, let's actually use it. And most of the time you want, or at the very least should, use a sprite class. Meaning I want to create a tile, and this one inherits from pygame.sprite.sprite. And this one needs a dunder init method. Here we need self as always, then we need a position, and then we need a surface. And now in here, we need self.image. That's going to be the surface, and we need self.rect. And for self.rect, we get self.image.get_rect, and we want to place the top left wherever the position is. And this is then just about the easiest kind of sprite class you can create yourself. Oh, I did forget, we do need super and the dunder init method. And in here, I guess we can pass in the groups the class should be part of. And this should also be a parameter for the init method. So now this is actually the most simple kind of sprite class. I have been recording for a while. Sorry about that. Okay, now, when we are creating the init stuff for the actual Python code, so this part here, I want to create a sprite group or whatever you want to call it. And this one is just going to be pygame.sprite.group. And now in the game loop, all the way at the bottom, I want to call sprite group.draw, and I want to draw on my screen. And now all we have to do is add sprites to this group, and then we can draw it. And just thinking of it, if none of what I have just said makes any sense, check out my introduction to Pygame. That is going to help you a lot. Now I basically want to cycle through my TMX file and populate all of this with different tiles. And I suppose, let me put all of this at the bottom and add a fresh section here. Now, first of all, I want to cycle through all of my layers. And this I usually do with for layer in tmx data.layers. And now I have to separate my tile layers from my object groups. And as far as I could find, there wasn't really a good way of doing it. And there are two ways to approach this. First of all, you could check if layer.name, that is not how you spell that, is in, and now you write some strings like floor and plants and rocks, and I think another one was pipes. So this way you're selecting specific layers and you yourself know that there are tiles inside of these layers, which I suppose works, but really isn't the ideal approach because it's very manual. Although I suppose there are also situations where you do have tiles you don't want to be shown. And in that situation, this approach would be quite useful. However, another approach would be to check the different attributes, because tile layers and object groups have different kind of attributes, and we can go with that. And I know that the tile layer has the data attribute. So I can check if has utter, I want to check my layer, and I want to check for data. And if that is the case, I want to print my layer. If I run the code now, we are getting an error because I didn't comment out everything properly. Now let's try this again. There we go. Now we are only getting the tile layers. And in here also, I do not want to work with ground because this one is invisible. So what I could also do is instead of layers, look at visible layers. So now if I run this, we are only getting the visible tiled layers. And now what we can do in here is what we have done in here. So we're using layer.tiles and we're getting X, Y, and the surface. Which means I want for X, Y, and surface in layer.tiles. And now that I have that information, I need to convert these X and Y positions to actual positions we can use. Which means in my case, I just want to multiply the entire thing with 128. And this I want to do both for X and Y. And all of this should be in the position variable. And now with that, I can get my tile. Position should be the position. The surface should be the surface. And groups should be my sprite group. And now if I run this, we can actually see something. Now there's a bit of a problem. Let me go to tile to visualize what's wrong here. Basically, what we are seeing in the game is this part here, more or less. Which isn't ideal because we don't have a camera set up yet, so we can't see all of the actually interesting stuff. But I guess an easy way to fix this is if I use my floor, I can draw some grass. So let me draw some here. So we have something a bit more interesting to look at. And I guess we can also draw some dirt. And then for plants and rocks, I want to, was it in objects? Yes. So let's place in the objects. I want to place a castle here, a tree here, here, and here. I know, a couple of mushrooms we could place randomly. It's really up to you what you want to do. And now, really importantly, don't forget to save, so this actually shows up in the game. And now if I return and run this again, now we can at the very least see the ground. We can't see the castle yet because we didn't cover objects. But at the very least, something is working. And well, for the objects, all we really need here, since our case is fairly simple, is for obj in tmx.data.objects. I can just reuse my tiled. And in here, we need a position, we need a surface, and we need groups. And this, I think, could be a good exercise for you. Try to figure out the arguments for these 3 parameters and see how far you get. If you paid attention, this should be fairly easy. All right, let's go through together. First of all, we need the position. And the position here is going to be obj.x and obj.y. And important here, this is not on a tile set. So both the x and the y position is just information we can use straight away, which makes it very easy to work with. Meaning the position we have already covered. Next up, we need the surface. And this one we can just put straight into the argument because all we need is obj.image. Although this is going to cause problems in just a second, but we'll cover that in a bit. And for groups, I want to have my sprite group. Now, if I run this, we will get an error because we have a non-type. That for some objects, we don't have an image. So what we can do, I suppose that's the easiest, if obj.image exists, then we want to create a tile. And now if I run this, we can see the castle. It's a bit stretched out, so this isn't looking too great, but at the very least it is working. And that's all I'm caring about for now. The mushrooms do look much better. And in here, using obj.image really isn't the cleanest way. Ideally, you would want to have clear names for your different objects. And let's have a look at this in tile to really visualize what I mean. Here again, we have all of our objects. And ideally, every single object has a name and a type. That makes it really easy to work with them. So right now, this one here should be a castle, and this should be a building. And all the other stuff is type vegetation, and the name for these trees should be tree, and then all the other elements are mushrooms. And this is looking much better. So when you work with objects, really make sure to name things consistently. It's very easy to forget. All right, now back to the code. What you want to do in here is more something like if obj in either buildings or in vegetation. So if I run this, we can't see the castle because I think this was building. There we go. And now if that is not the case, so else, then I am working with the shapes. And for those, the tile class isn't really going to work. So I'm going to do this slightly differently. Let me get rid of this and copy all of this here instead. And then I want to go into the game loop. And on top of the group, I am going to draw all of these shapes straight on the screen. So what I first of all want to check if the object type is inside of shapes. We are working with all of these objects here. And just to make sure we can actually see them, let me move them all on the screen, or at least some of them on the screen. There we go. This is definitely going to be visible. And again, don't forget to save, really important. Now, in here, I want to check, actually, I can copy all of this here, make my life a bit easier. And let me uncomment all of this. And let me put these things after each other. All right, so now we have all the information we need to draw markers, rectangles, ellipses, and polygons. Now, markers are the easiest ones, and we already have the X and the Y position. So what we could be doing, for example, is pygame.draw.circle. And for this one, we need a surface, which in my case is screen. Then we are going to need a color. Let's say for this one, we can use red. Then we need the center, which we have. That one is going to be obj.x and obj.y. And then we need a radius. Let's say in this case, we can go with 5. And let me comment out or delete these 2 points and comment out all the other stuff so we're not spamming too much text. And now if I run this, we can't see anything. For the simple reason that this should be shape instead of shapes. So here we can see 1 point, and there we have another point. Obviously, this isn't too useful, but I think you get the principle. Now, next up, we have the rectangle. And I think the easiest way to work with this is to turn this into an actual rectangle. So pygame.rect. And then here we need left, top, width, and height. And if you look below, we have all of these points. So obj.x is the left side, obj.y is the top, and this is horrible spelling. Then obj.width is the width, and obj.height is the height. Meaning now I can get rid of all of these points and call pygame.draw.rect. I want the screen again. This one I want to be yellow. And I want to have my rectangle. So if I run this, we can see the rectangle as well. Next up, we can work on the ellipse. And for this one, basically what I want to do is pygame.draw.ellipse. And in here, we first of all need a surface, which is my screen. Then we need a color, which in my case, let's go with blue. And now we need a rectangle. And the rectangle, let's create it separately again, is going to be pygame.rect. And for this one, I can just copy all of the stuff we used for the rectangle and just paste it in here. And now we have a rectangle, so I can run this again, and we get the rectangle we created. And finally, we have the polygon. And for the polygon, I only really care about the points. So if I run this, just to see what we get, we have all of these points. We basically get a list, and the list contains point objects, and each point has an X and a Y attribute. And those we have to extract first of all. And for that, let me get rid of all of this. I want to create a points variable. And I'm going to use list comprehension to extract all of the points. And for now, I want point for point in obj.points. And I don't want the point itself. Instead, I want to have a tuple that contains point.x and point.y. And if I print these points now and run all of this, I get a list full of tuples with the X and the Y position. And this I can use for pygame.draw.polygon. And polygon only wants 3 different arguments. It wants a surface, which in my case is screen. Then for the color, something we haven't used yet, let's go with green. And points is going to be points. So if I run this, we can see on the right side the shape we have seen earlier. And well, that is pretty much all you are ever going to need. So I hope that was helpful, and I see you around.